Hi, my name is Logan Marks, and this is my Arduino Assignment 1, Part 2A, Part 2B, and Part 2C. For Part 2A, as you can see, the objective was to view a signal of a potentiometer. This was an example of an analog sensor opposed to the 0, 1 signal display of a push button. We can demonstrate an analog input by reading an analog sensor on the analog pin 0, which we set. On the first line, you can see we initialized the sensor pin to be equal to A0, which was the input pin for the potentiometer. We initialized a variable called output value, which was equal to 0. That was created to store the output value. We initialized a variable called sensor value, which was equal to 0, and that was initialized to store the value of the values outcoming from the sensor. We have serial dot begin, which allows for the communication between the computer and the Arduino board. The sensor value is equal to the analog read from the sensor pin, which we had set to be A0. All right, and the output value was equal to that sensor value. So that outputs a sensor value, and then the serial.print sends that value that we got, the output value. It transmits that analog signal back from the potentiometer to the computer, so we can view that.
Here we have the setup for my Arduino assignment part 2A, which utilizes an analog sensor this time, which is the potentiometer. The potentiometer is wired into the analog O input of the Arduino board. And as the knob of the potentiometer is adjusted, the signal is varying accordingly on the Arduino program, and you can view that result of the signal both numerically and graphically, and I can show you just that. So there's the code. I'm going to verify it, upload it, and I will show you first of all numerically with the serial monitor. So right now at the start, the knob was actually turned all the way, and that is the max you can see is 1023. I'm going to begin. And as I adjust the knob, the signal varies accordingly all the way to 0. And the same thing can be done graphically. So as I adjust the knob, the signal can be viewed graphically.
Part 2B had similar objectives to Part 2A, as we were trying to read the signal from a potentiometer, which, yes, was an example of an analog sensor. This time we are scaling the potentiometer signal from the raw range that it had from 0 to 1023 to a range that we would like to be from 0 to 5. We're going to use the floating function to allow for the results to be displayed with decimals. So as you can see on the first line, we have a serial begin. That's to allow for the computer to communicate to the Arduino board. And then we initialize a sensor value to be the analog read of the potentiometer pin. And then we have float voltage, which creates a variable named voltage, which is equal to the sensor value determined by the knob of the potentiometer. And then the range is mathematically scaled down according to the range that we wanted. So that was the reason for the multiplication there. And then we have serial print, which the scaled voltage value that we created in the line previous is sent to the computer for us to view. And we can view this both numerically and graphically.
Here we have the setup for the Arduino assignment part 2B. It is actually the same circuitry as the Arduino assignment 2A. The only difference is this time we want our results to be displayed in a little bit of a different way. We want to scale the range of the results. Instead of being able to go from 0 to 1023, we want our range to be scaled to 0 to 5, and we will achieve that by using the float function in the Arduino code. And that these results can be viewed both numerically and graphically. So here's the code. Let me go ahead and verify it. I'm going to upload it. Oh, actually my thing wasn't plugged in. Okay, now it's plugged in. Let me upload it. Okay, so we're gonna go to the serial monitor. Before I start turning the knob, okay, and you see this away we can get decimals now in our answer this away. There, I'm turning the knob. Much more precise. We can get that to go all the way to 5. And I can show you the same thing graphically. The serial plotter. Yep, from 0 to 5.
Here we have 2C, which is very similar to both 2A and 2B, except this time we're going to use the map function to change our range from 0 to 5, but in integers. With the float function, we were able to see our display our results with decimals, but with the map function, we will have the Arduino program automatically scale down our range for us. Also, with the float function, we had to mathematically scale it down. With the map function, it automatically does the math to adjust the numbers to the range that we decided on, and in this case it's from 0 to 5. So all of the beginning of the code is the exact same. So I'm going to take you down to the output value equals map sensor value right there. That uses the map function to automatically scale down the range that I was talking about. So we have the sensor value in the parentheses, and then we give it the value that we want it to go from the range of 0 to 1023 to the new range of 0 to 5. And no math, there's no multiplication involved in the code like there was for the float function. So that's a little bit different there, and the results will now be in integer form.
Here we have the setup for the Arduino part 2C. Similar to the part 2B and part 2A, actually nothing has changed on the breadboard. The only thing that has changed is that the way that we're going to get our results. Last time we mathematically scaled our results down to a range that we wanted between 0 and 5 and used the float function to get our results into decimals. This time we're going to let the Arduino program automatically scale down to our desired scale using the map function. And those results can be seen numerically and graphically. Here's the code. I'm gonna verify it. Upload it. We can start with the serial monitor. See how the signal changes as I turn the knob. You can go up to 5. If I show you the serial plotter, can actually go up as well.